Now we shall discuss about the rate of change in respect to displacement and time, that is velocity and acceleration. Usually displacement is expressed in terms of time. So displacement S is a function of time. When we differentiate with respect to t, this becomes f dash of t, and ds by dt became rate of change of displacement, which is nothing but velocity. So velocity can be obtained by differentiating displacement with respect to time. The acceleration can be obtained by differentiating velocity with respect to time, because rate of change of velocity is acceleration. That means it is the second derivative of displacement with respect to time. So d2s by dt square gives me the acceleration. If you differentiate displacement with respect to time once, velocity, second time if you differentiate you get acceleration. Now imagine you are given v as a function of s. That means relationship between velocity and displacement is given to you. In that case, how will we find the acceleration? So dv by dt is your acceleration. That means you need to differentiate dv by ds into ds by dt. ds by dt is nothing but the velocity. So v into dv by ds will also give me acceleration. So there are two ways to find the acceleration. If velocity is expressed in terms of time, differentiate velocity with respect to time, you get acceleration. If velocity is expressed in terms of displacement, velocity multiplied by derivative of velocity with respect to displacement also will give me acceleration. So there are two types of problem. One, relation between velocity and displacement is given to me. Let's imagine v is equal to 2s plus s square. I want to calculate what is the acceleration. So I will differentiate v with respect to s. So 2 plus 2s. Then acceleration is velocity multiplied with the dv by ds, which will become 2s plus s square into 2 plus 2s. This will give me the relation between displacement and acceleration. So this is a way we can calculate in case of velocity given as a function of displacement. If velocity is given as a function of time, then acceleration can be obtained directly by differentiating with respect to t. So 2t plus 3 will give me directly the formula to calculate the acceleration. So there are two ways to find the acceleration. One from velocity to directly differentiating velocity with respect to time. Another by differentiating velocity with the displacement and multiplying with velocity again, you will get the formula for acceleration. A particle is moving with the formula given by displacement is 9 times t square minus t cube. T is the time. You got to find the velocity when the acceleration becomes 0. So I start with s is 9t square minus t cube. Now I am going to calculate its velocity. So velocity is obtained by differentiating with respect to t. So ds by dt is 18t minus 3t square. So velocity is 18t minus 3t square. Now I'll calculate the acceleration. V is 18t minus 3t square. If you differentiate this with respect to t again, we will get dv by dt. So dv by dt is the acceleration, which is 18 minus 6t. 18t is derivative 18, 3t square is 16. You want the acceleration to be 0. So 18 minus 6t should be 0. So t is equal to 3. So in the third second, the acceleration will become 0. We are asked to find when the acceleration is 0, how much is the velocity. So when time is 3, acceleration is 0. At that time, velocity is 18 into 3 minus 3 into 3 square. That is 18 into 3 gives you 54. 9 into 3 gives you 27. So it is 27. Have they given us any unit? They have not given us no unit. So I am also writing without unit. So velocity is 27. A stone is thrown upward So it moves up and it stops at the maximum height. The relation between the displacement and time is given by this formula. We need to find out what will be the height, maximum height the stone can reach. That means we need to find out at what time the stone will stop moving. That means what time the velocity will become zero. At that time, what will be the height? That will be the maximum height. So we start with S is 294t minus 49t square. Velocity is ds by dt. So 294 minus 98t. Now, velocity will become zero. So 294 minus 98t should become zero. That means 98t should be 294. So t will be 3. So in the third second, the velocity at the top will be zero. That means the stone will stop. At that time, how much the distance would have been covered? That is given by this formula. So I need to replace t by 3 here. So S will be 294 into 3 minus 49 into 3 square. That will give me 294 into 3 minus 49 into 9. So it is easy for me to calculate by taking a 3 common. 294 minus 49 into 3. So 147. So 3 into 7, 5, 157. 147. That gives me 441 will be the maximum height that can be reached is 441. If in these problems they have not given us the unit, so we will keep your answer also in that. So the maximum height that this particular stone can reach is 441. Okay. In this problem, the relation between velocity and displacement is given. X is the displacement, distance from the origin. V is the velocity, and you got to find the acceleration. So we know that acceleration is V into dv by ds. So S, instead of S, I'm using X here because X is the displacement. So acceleration is V. V can be, first we'll find out dv by dx. So for that, A plus B V square is equal to X square. So differentiating with respect to X, with respect to the displacement, A plus B into derivative of A, so d by dx of A into d by dx of V square is equal to d by dx of X square. So this became 0 plus B into 2V dv by dx is equal to 2x. So I can cancel the 2. So directly I can obtain V dv by dx. So V dv by dx is x upon b, hence acceleration is x upon b is my answer. So directly I was able to obtain V into dv by dx. Initially I was planning to substitute V, but when I differentiated V square, V dv by dx came. That is actually the direct acceleration. So acceleration is x upon b.